Okay, it started. So, do you guys see my screen?
Yes, I can.
Yes. Cool. So, today we will talk about, um, first of all, welcome to the session on unlocking the power of data models. So, before starting the session, have you used the data models before or not in your current or previous, clients?
Yes, we did
Right?
leverage data model
Okay.
in the security enterprise security app.
Yes, in security, most people will use data models.
Yeah,
Without data models, we can't run the searches.
yeah. Even for developing some of our custom use cases, we have leveraged that data model.
Okay, okay, okay. So let me go to the next slide. So in today's agenda is we'll talk about first thing is about introduction about me. Like this is Venkatesh. I'm the Splunk consultant from Bitsivo, working in IT for the last 9 years. And I joined Bitsivo in the 2021. From there, supporting different different clients for Splunk engagements. And we'll talk about what are data models and why we use data models and what outcomes we get out of this. And we'll talk about best practices and advantages of data models. And finally, we'll talk about data model acceleration centralization technique that introduced in 8.0 version. From 8 version, they introduced that one. And we'll wrap up with a small demo. Okay. So now let's dive into uh, the first agenda. What is it is like what are data models? So So what are data models? By definition, by definition, it's a search time mapping of data into a hierarchical structure. Okay, didn't understand, right? No worries. So what it really is, it's a collection of objects that have constraints and attributes that also have child objects that inherit those constraints and attributes. All of this is, like I said, it's a hierarchical structure. Even if you don't understand, that's fine. When we go to the demo, you can clearly see, what is hierarchical structure, what are these constraints, what are these attributes. Everything will be covered under there, but it's a definition of the data model. So okay, now we discuss about data model, how we can build data models, how many we can build this data sets based on two types. One is root event dataset, other is root search dataset. As I mentioned in the screenshot here, there are two types of datasets. Using two types of datasets, we can build it. Let's talk about these two types, starting with root event dataset. Root event dataset represents a set of data that is defined by a constraint. Constraints looks like the first part of a search before 5 characters, and additional such comments are added as shown on the right hand side image. So root event data search is nothing but, we can add any constraints here, but here we don't add any characters or anything after pipe. We don't define any transforming commands or streaming commands or anything. We don't define any of those. We just mention just a search and or the root keywords that we need to build the data model. So let me explain these constraints. Usually, constraints for the root event dataset are designed to return a fairly wide range of dataset. A large dataset can give you something to work with when you associate child event dataset. As each child data, as each child event dataset adds an additional constraints to the ones it inherits from its ancestors dataset, narrowing down the dataset that it represents. So what is it? What does it mean is the root dataset has a large number of um, it's a large data sets. Like when you define just internal equal to index and just you mention the source, which means it's a large data set. It has lots of data. Every fields, I mean, all the fields will be displayed from this root data set. So that is about the root event data set, which means you can access any number of, I mean, all the fields that are, I mean, that are in the this internal index. I mean, this here I took this as an example, this data model, which is Splunk internal server logs. You can have other data models like web server, web data model, or firewall, or change data models. We have different data models. I will show you in a bit. I mean, in the demo. So now let's talk about root search dataset. Root search dataset enables you to create dataset hierarchies where the base dataset is the result of an arbitrary search. In this I mean, root search dataset, you can use any SPL in the search string that defines the root search dataset. So for now, we have two kinds of datasets. One is root event, other is root search. So now here you get a question like when to use what data set. It's all depends upon the use case. So data sets can be only accelerated if they contain at least one root event data set, or one root I mean one root I mean sorry or one root search hierarchy that only includes streaming commands. So if it contains any non-streaming commands or root transaction datasets, then we can't accelerate that particular dataset. And also, once we accelerate the data set, we can't edit the data model. So if you want to edit it, you want to stop the you want to stop the acceleration, and then only you can edit it. Otherwise, you can't. Right? So, so other thing is like, when do you want to use data models? Data models are really good when data models are really good way for someone with more knowledge of data to organize and normalize your data, that then allows somebody with less familiarity with your data set to start leveraging and getting value out of it. Which means, for example, in your organization, you have two people. One is the admin and one is just a user. And user doesn't know about much about the data, but the admin knows everything about the data, and he built a data model. From that data model, he can the user just user can leverage the data model and get some value out of it from the data model that we created. So next slide. Now let's talk about why we should use data models. So there are mainly three reasons. One is fields, pivot, and common information languages. First, let's talk about the fields. Let's say we onboarded data from three different vendors, such as Cisco, Juniper, and Palo Alto. They may develop products with similar roles, and they're often logged in different formats. The data will be, logged in different formats. From this data source, I have a same field for these three different vendors, but it's three different names. So, for example, Cisco might have a CIP as a source as a CIP, and Juniper has a source IP, and another data set might have a IP. Guess what? All same. I mean, it's the same thing. Someone is calling it as a source IP, someone it is calling as a IP, or someone is calling as a CIP. But it has it's the same data set, and but it has still three different fields because it is onboarded from three different data sources. That's where we use data models. So once we combine all these three fields into one field called IP, then we can, using a common information model, um, then it will be easy to identify using one data model. So now, once you do that, so now instead of having CID, source IP, IP, guess what? you have one field and let's say you call it as a IP. That's it. That's pretty simple and pretty straightforward. So that's the
So it's
one.
like
Yeah.
it's like common name that we give to that field, SRC or IP,
Or
and
CI.
and then that is what requirements are of CIM,
Yes.
and that's how we make all the fields that are required for CIM common fields and
Yes.
map it to the common name.
Common name. Yeah. So you don't need to worry about, okay, we are calling the same field with three different names when you use this that particular data model.
Got it.
Yeah.
Thank you.
Okay. And now moving to the pivot. So uh, a lot of people have heard about data models. They have seen them. They might use, as you mentioned, Dheeraj, in the people using within the ES or maybe out of the ES. But here is the thing. Does everyone know exactly how to write all the SPL that goes into the data model? Probably not. So there are a lot of different ways the data model can be used in a way that we can display the data. But Splunk has given us an awesome tool called Pivot. So within the Pivot interface, it really allows you to display all the data to the end user. It displays all the data, whatever the data we have in that particular data model, it displays. And they can work with or without having the knowledge of anything about the SPL. So they can go ahead and they can drag and drop the fields from the pivot, and they can choose the fields they want to they want to use, and then they can lay it out some beautiful visualization chats, or whatever visualization they want to, they can do it. So you can give any analyst who doesn't know the first sight about Splunk access. If you provide access to the pivot, they can easily create their own reports or dashboards that useful for their team. And the other main advantages of this pivot is, a lot of people don't realize is that behind the scenes, when you use the pivot, even if your data model is not accelerated, which will get here shortly, but the pivot still uses some form of acceleration on the back end of it. I mean, sorry, from the back end. Even if your data model is not accelerated, it will utilizes some form of acceleration, and it will get you the results. So you will get the benefit of accelerating without having the data model, without having to have the data model accelerated. So that's the reason. Like, so the advantage of the pivot is, without accelerating, you get the results of accelerated results. Okay. And again, coming back to the common information model, as I said, in the fields, we can use the common information model to normalize the fields when you have different, same kind of data from different sources. Okay. Now let's talk about when to consider the data models. So until here, any questions or anything? Any doubts or any questions?
So if I am someone who does not know the Splunk query language,
Mhm.
Pivot is a good option for me. I can
Yes.
uh, leverage the pivot and generate a report.
Yes. And using a pivot, as I said, like, even if your data model is not accelerated, when you are using pivot, it will
Okay.
accelerate some part of the data, and it will provide you the results, which this process will be done on the back end, which we can see from the UI.
Okay. Great. Thank you.
Okay. So here, now let's talk about when to consider a data model and when not to use a data model. So as I said, data models are good if you have multiple data sets across multiple source types, but you want to bring all them together to look holistically set of data. So if you have a lot of network traffic from various different devices, but there are different source types, you can bring all them into a network data model, and going to normalize all your fields like IP address, URL, user, whatever it is, status, all and so on. You can normalize it. You can bring all the network data into a network data model. Similarly, for uh, web traffic, you can get all your data into using into the web data model, and it normalizes all your fields. So it's by normalizing all those fields, it make you easier. The query makes you the easier the data model. In addition, in addition to that, like the first use case is like when you have different data sources, but it has belongs to the same data model, then you can use the data model. The other thing is, once you have the data model, you can accelerate it. Once you accelerated it, the performance will be much faster, because when you query for any particular data from the data model, it takes the results from the TSIDX files, not from the raw data. So that's the reason the queries will be much faster when using the data model. So now let's talk about when it's not a great idea to use a data model. Data models might not be a good case when you have unique set of data, something that is not traditional web traffic, maybe something that is not traditional network traffic, maybe it is a custom in-house application. I have worked with some of these where it's a custom in-house application. The fields are all specific to that particular application. It doesn't really present itself well, which means which means all this custom in-house applications have their own fields. It doesn't match or replicate to the any data models. So in that case, it's not a good idea to use a data model. But before that, you need to ask yourself, are there really advantages of trying to force that particular in-house data into a data model or not? Because if you think that, okay, even if it is a doesn't fit into any of the data models, if you want try to fit into any data model, it's a waste of resource on the indexer. Instead of that, you can directly query using the index and source type and then event type, or any fields that you want, you can directly query it instead of using a data model. That's one use case. The other use case is, um, when you want to look the data, and you want to implement, and the data model doesn't have those fields, then it's better to use better not to use that particular data model. For example, let's say you have let's say you have a in-house data model, and no no let's say you have a data model that is network traffic data model, and you want to use in that network traffic model, you don't have one of the field, but you want to put that you want to extract that field into, you want to add that particular field into your data model. Then it's not a best practice for that particular field. No need to add an extra field to the data model, because if you add other field, it you want to accelerate it, the data model accelerates, and it consumes other little bit of resource in the on the indexer. So no need to have all the fields in the data model. So when you should avoid data models is when you have a custom in-house application, or if the fields are related to custom ones, then you don't need to go with the data model.
So, if I have a data like a network data,
Hmm.
or traffic data,
Hmm.
and I have a field, and that field for that particular log source is not mapped to the requirement of CIM, like the common name of the CIM.
Hmm.
So, I mean, I can still use that field, Maybe I add an alias
Oh
or
yes, it's all depends on the use case also. Like if you want to, I mean, if you are running that query quite often, then you can add that field to the data model, and then you can use that particular data model. But if
got
you're
it.
not using that particular field quite often, you're just using like once a month or twice a month, you don't need to add that particular just one field to the data model and make it accelerate, right?
Got it.
So in that case, it's not a good practice to use the data model.
Got it.
Okay. So now let's talk about the outcomes of the data model. So, okay. So here we'll go from in anti-clockwise direction. The first and the number one thing is it increases the performance. Why it is increases the performance? Because we are accelerating it. So with the acceleration of the data model, the performance of the searches will obviously increase. And coming to the point number two, part of the data acceleration, it creates a summary index. So rather than querying the raw data or the raw log files, it queries the TX-IDX files, which is much smaller set of data, which makes it fast, which makes it much faster for those queries. In addition, you have a simplified fields and searching reference. So again, going back to my example at the beginning, instead of having 5 different names for a particular field, using it through a common information model, it now normalizes into one single field. And you can easily customize data within a data model by either adding a additional extra fields, or by adding a calculated fields, or by adding a lookup field, or any standard set of fields in the data model. Doesn't mean that you don't have ability to modify those along the way. So in addition to the increased performance, one of the biggest thing is your search time is being greatly reduced. We'll cover this in the demo. We'll talk about why this search time is greatly reduced. And the last thing, I think what is most interesting and most advantageous about the data model is the way to make common set of references for very different sets of data. So you can have data from 5 different vendors that might all produce similar data, but it's not exactly same. But now you can take all those different source types and you combine them into a data model, and you can now refer everything and get a holistic picture of that particular data source. Understood? So the main performance, it will increase the performance, it will reduce the search time, and then we can simplify the fields, and we can easily ability to customize the data. Like we can add the fields, we can remove the fields, we can add the calculated fields or lookup fields. We can do that, and excuse me, and we can combine the different data sets into into one field using the common information model. So now let's talk about the practices and advantages. So before you creating a data model, you need to have a solid understanding of your data. Without knowing the data, you can't go ahead and create the data models, because it unnecessarily creates lots of storage issues on your indexes. And always use event objects as often as possible. Yeah, which means you should not use, I mean, you can use such objects also, but to accelerate it, you need to use the event objects. If you want to use the search objects, make sure you're not using any non-transforming commands, non-streaming commands too. So minimize the depth when possible, which means adding more layers will slower and complex things, will slower the data model performance and makes complex also. So minimize the depth, which means adding a child objects, or adding a constraints. It makes slower and complex things. So minimize the depth. And coming to the advantages, without knowing the SPL, using the pivot searches, you can easily create some reports for your team. And other thing is, you can accelerate and you can accelerate the data model, though, so the such performance will be much lesser compared to running the data from from the index. And also it combines various source types into various source types fields into one field, and have a unified picture, right? And coming to the data model accelerations, data model acceleration is for improving the search performance. And also here the other thing is, here I mentioned data model centralization, which means, let's say you have two different subset clusters. Okay, but it's using the same, but two clusters are using the same indexer cluster. So, and which means, why we have to separate subset cluster means, on one subset cluster we have the ES, on other subset cluster we have remaining apps. Usually for enterprise security or ITSI or any other premium apps, we also we need to have a separate subset environment. We should not include with the regular environment. So since when we have two different subset clusters, and you want to when you accelerate the data model on one of the subset cluster, and you don't want to you and if you want those results on the subset one, you need to accelerate on the both subsets. When you do that, it will increase the unnecessary space on your indexes. It will take the it will take up unnecessary space because we are accelerating on both the clusters. So to eliminate that, what we can do is we can go with data model acceleration centralization, which means, let's say, on one of the subset, you're accelerating the data one of the data model, which means acceleration equal to true. So on the other subset, which is part of the same indexer cluster, you want to use this results and on this particular subset. Then what we'll do is we'll add an acceleration source GUID of the subset one, so that this particular subset, I mean on this particular subset, this data model will also be accelerated, but without accelerated in the sense, it won't accelerate. It will take the data from this subset one and it will replicate here. We'll see in a demo that. Okay, so let's dive to demo session. Do you guys see my screen?
Yes, I can see it.
Okay, so here we have two subsets. Okay, one is 242 and other is 237, which is using same indexer cluster but different subsets, distributed subsets. So here, first let's go to the search settings, data models. Okay, so here, first let me talk about how to create a data models, right? So When you go to the settings and then data models, this page will be open. And then here you can create a new data model, and we can give user group. mm, mm, Testing data model. Just we can give whatever the name you want, but make sure it is unique. So as I said, we can create data models based on two different data sets. One is root event and root event search. When we do using the root event data search, it has huge volumes, huge data sets. For example, I want to create a Splunk uh, server data set, and here we use only just the index, source type, keywords. Only we use the source, those things. We don't use any pipe or stats or any of those comments. We don't use here in the constraints. So here internal, and then we can mention, if you want, we can mention the source. If you want to look for any particular source or source type, we can do that, and then we can preview it. So this is a large data set. We are not filtering anything here, right? So this is, I'm just saving it. So now from this from this data set, we can add other constraints. Or first of all, yeah, from this data set we can add other fields. Like for now, it will inherit only these fields like host, source, and source type. If you want to add other fields, because in the internal index, since we take the internal index, here we have the other fields, right? Like auto extracted fields. For example, here I want to um, take the component, and yeah, maybe I can as required, and I can save it, and then I can add auto extracted fields here. If you see here, maybe some fields might not shown up here. Then what you need to do is you can scroll up and add by name. If you don't see some fields, you can do it like this. I want to add name, and name. I know that we have a field called name, so I'm just adding
Venkatesh, what I see is the Splunk search hit 237.
oh,
Um, yeah,
237 you're seeing.
yeah, just the search hit web console. So I think we
uh,
so the yeah.
uh,
Now we see that. Now
you see.
we now we see the data model. Yeah,
Okay. Oh, okay. So you didn't see from the starting, like when I.
yeah. The we just see the search hit.
Okay. Sorry for that. So yeah, first of all, when you want to create any data models, just go to uh, data models from the setting, and then here you have a new data model tab. You can click on it. Yes, just use a group data model, and then just create it. You can see now, right? You are able to see now, right?
We see the data model, uh, this testing data model page.
Oh, you see now that there, that page,
Mhm.
is it lagging or no? Which page you can see now? Which page it
It's
is?
the top. It says testing. It's 242.
242. Yeah. Okay.
Mm, yeah.
So are you able to see these fields, the extracted fields?
Yes. Host source source type component name
Oh,
index equals underscore internal.
okay. So in the, yeah, so from this internal index, there are some fields. If you want those fields to be in this data model, you can add those fields by auto extracted. So
Okay.
yeah, here you have, command, or I just want to use current size, and then save it. So we can edit here, and if you want this To be required field, you can keep that as required and you can preview it. Yeah, names, you can see those names and then you can save it. And sometimes if those fields are not showing up when you're doing auto extracted, you can add those fields by add by name here. The reason why I said you need to understand the data before creating the data model is that's the reason, because here you can't see all the fields here. It has a limitation. That's the reason. If you know about your data and if you know what other fields you have, you can add those fields using the field name here by giving the field name. Okay.
Okay. Mhm.
Yeah. And even if you don't know about the data, just go to the search and do index equal to, since we are doing for internal index, just go to the internal index, just on in neighbor push mode, just yeah. And you can see all those fields here, right? So since I know about name and thread, all those things, if you see
I
here,
think, sorry, Venkatesh, I think you are doing in a different console. Uh,
um, do you able to see now 242 screen?
yeah, I can see 242. It has on the top underscore testing.
Yeah. Yeah, what I'm trying to say is we're adding the some fields, right? Extracted fields right here. So when you want to add those fields here, just go to the add field, auto extract. Do you see this page now? Hello.
Um, no, I think it's the same screen.
Uh, just user group testing. Dheeraj?
Yeah, the group testing one.
Uh, maybe it's a, I think there is a lag here.
How
Yeah.
about Hari and Ashwin? Are you seeing the same things as I am?
Yeah, I see the underscore testing, the constraints. That's the screen I see.
Okay. Mm. Okay. But you see this add field option here, right? On the right hand side.
Yes, the drop down add
Yeah.
field.
Add field. So
Yes.
here you can add these extracted fields from auto extracted, from the eval expression, from the lookup, and from the regular expressions. All those are from the GeoIP. You can add those fields here. Then it will show up as an extracted and eval expression and lookup. All those things it will be shown up here. Okay. So once you accelerate the data model, you can't see these edit options. Okay. So coming to the main data model, yeah, coming to the main data model, let's take this as, since I already accelerated this data model, so I want to show you how to use the pivot also. So go to the pivot option from the data model. Do you see this screen now?
I feel it's the same screen.
Hmm. I'm sharing.
Are you sharing the screen, all the screen? Probably it may be related to sharing.
No, I'm sharing the same screen. And mm,
Do you want to stop sharing and share again, Venkatesh, just in case?
yeah, let
Yeah,
me let me do that. I don't know why it is stop presenting. And let me start sharing and that screen to share. Do you see my screen?
Oh, I see. Select a data set, that page.
Okay, cool.
yeah.
So, yeah, let me go back one step. So now I just want to show you like how we use the pivot. Okay. So I just want to go to the pivot. Okay. Do you see now select dataset screen?
Yes, see select a data set,
Yes.
20 matrix. Yeah.
Yeah. So here we have all the fields that are defined in this particular data model. So here I just want to, create a small, query based on the queues. So here what I will do is, since I have all the fields, I just want to go with the queue name. So I will split by the name, queue name. You can give the name, whatever the name you want, or you can just leave as default, and then you can add to the table. And here how you want to count it. So I'm just adding this one. I want to do a current size on this queue name, and I want to do an average and add to the table. And I just want to delete this one. Do you see now the queue names are showing up and their average current size is showing up here? Do you see?
Uh, I see only the select a data set page.
Uh, it is, the screen sharing is too slow, I think so.
Yeah, I don't think it's loading up yet on our end.
Oh, let me stop and share again. It's entire screen to share. Yeah. Do you see now?
Yes, I see the average size and the name.
Yes, when I navigated to the pivot, it showed all the fields, data set field, and then from there I splitted the rows and the I want to calculate the average on the current size. I selected all these things, and it's showing up. So even if the user doesn't have SPL knowledge, they can create some reports or alerts based on this pivot thing. And you can see here, you can inspect it. How long does this query took? It is 53.19 seconds, right? So this is one way of representing the data. The other way is, uh, go to the search, open in a search, and you can use the internal index also, right? You know that, right? From the data from the index, we can calculate the average size by name. I want to use the same thing, but using the, instead of pivot, I know like where the data is. I know what are the sources and what are the filters I need to use, and then I know how to use the stats. So I'm just using this one. And if you see here, inspect job, do you able to see this screen or not yet?
I see only the new pivot page.
Oh my god. Hmm. Let me stop and share it. That's the only way today. Okay, screen, share screen. Do you see now?
Yes, I see a small dialog box as job inspector.
Yes. So here what I'm trying to do is I'm just trying to run the query using the because I know from where from which index I have the data and what are the filters I need to use, how to use that. So I'm just using this one. So when I inspect here, it took 0.6 seconds. Do you see that one?
Yes.
Yeah. So yeah, before I use the pivot, now I use the internal index. So in the similar way, I want to use the tstats command. Okay. Okay. Or do you guys still see my screen, right?
Yeah, I see the job inspector page. Yeah.
Mm, it's related to that's Do you see now other screen?
Yes, the search results
Yeah.
with this.
So I'm using the same thing. I'm using the same server name and average of current size, but I'm using now t-stats. And if you see here, I'm using summarize only equal to true, which means since I already accelerated this data model, it will accelerate those data sets. So if you see now the job inspector and inspect phase, it took only 0.1 second. Do you see that job inspector or not yet? I think
No,
yeah. Maybe it's recording, right? Since it will show up in the recording. Sorry for that, guys. And the final thing I will show you, like I want to stop and I will share again. Let's see the data in me, but that's fine. And that screen to share. Okay, so you can see my screen, right?
yes,
Yeah.
the search results.
Yeah, this I'm using this tstats command. So here it took 0.1 second to run this data since it is already accelerated. So I want to run the same thing on the other search head with summarize equal to true. Let me know if you guys able to see the screen or not. Obviously no, right?
No, I just see the search results, no results found.
Oh, that's good. That's good. Yeah. So this is another subset cluster, which is part of same indexer cluster. So here so here it's not showing this results when I'm running because here the data model is not accelerated. That's the reason it's not showing up. Let's say let's do summarize equal to true instead of true. Let's do summarize equal to false. Um, do you see any results now?
Yes, see the
Yes.
username and average of current, server
Yes.
name and average of current.
Yes. And if you see here, the inspect when I do the inspect job, it took almost 15 seconds, right?
Yes,
So, but since it's using the same indexer cluster, since I already accelerated the data model on one of the subset, it I want to use the same accelerated data model here using the data model acceleration centralization method. So when I'm using the true, it's not showing up, right? So what I will do is, let me share my terminal. Do you see my terminal screen?
yes,
Okay, that's good. So let's start. Open terminal. Okay, and I need a password. Just give a minute. Instance. Okay. Okay. Now you guys see my screen, right? So I see. Right? Do you see the comments that I'm trying to type?
yes,
Yeah. So here what I'm trying to do, this is the search head which doesn't accelerated. So what I'm trying to do is I will call the search head one GUID into this particular data model. Sorry, into this particular search head. So what I'm trying to do is vi paste. Yeah. So what I'm trying to do here is I'm mentioning like acceleration equal to true, and then acceleration equal to acceleration earliest time is 1 week, and then we don't need this one. And other main thing is acceleration source GUID. Do you see the GUID? This GUID is taken from the search head one. This is the search head one GUID. Okay, I'm just trying to save it, and then I just want to restart it. Oops, then okay. The reason is okay. Of the stop. Do it fast. Okay. Okay. Sound minus hours. Outspec. Okay. Sudo yes, Splunk. Okay. Splunk. Then Splunk. Is that okay? Do you see my restart command here?
Yes.
Yeah. Okay. Cool. So I just added few changes to the data model.conf. So what I added here is, let me finish it. Yeah. So yeah, that data models.conf. So here what I added is I took the GUI ID from the search head one and I paste here. I added these standards internal server, which is the data model name, and then acceleration equal to true, and then other fee, other attributes, and then source equal to GUID. I took this GUID from the etc instance.cfg. Okay. So once I restarted, now I'm going back to the search head 2. Okay. Do you see this search head to screen? It's loading.
Mm-hmm. Yes.
Okay. Yeah. So here, before when we have this summarize equal to true, does it show any results? No, right? Now,
Yes.
since I restarted, when I do is rerun the search, see, now it showed with summarize equal to, I mean, equal to true. Now it's showing the results for that. And it is same thing here. When you do the inspect job, it takes almost 0.1 second. Yeah, 18 seconds. That's it. Before it took like 4 or 5 seconds. Now it's just 0.18 seconds. So
Okay.
just calling from the search at one cluster to the search at two. And similarly, if you see settings and then data models, you can see before it is not accelerated, but now you can see this acceleration more, this change in color for this data model. And if you see here, it won't show like, if you see here, source GUID detected. And if you see the same thing on these particular settings data model, it shows in a different way how much resource it is used, all those things. It will see here, it doesn't show like okay, rebuild, build, update, edit, and all those things. Actually it will show something like this. When we come to this one, it's just show update. We can't rebuild or we can't do uh, any changes to this data model on the subject too, because it is taking from the subject one. You understood, right?
Yeah. So it's actually pulling the data from the search at one.
Such at one, yeah.
Yeah.
By doing this, we can save lots of resource uses on the indexes instead of running again the accelerating the model this data model on the subset two. We just accelerating on just one subset cluster, and we are using same data set for on the other subset. So we can save some space on the indexes.
Okay, great.
Yeah. So that's about this session. And any questions? Or have you ever used this data model acceleration before? Or it might help you. I mean, if you use, that's fine. If not, it will help you. Yeah, okay, let me stop recording.